Hello everyone and welcome back to this fourth module of our workshop to administrate Azure. This is a session about virtual networks. As you can see, this is the fourth module of the track, and we will talk about the management, configuration, and administration in advanced mode, if you will, of our virtual networking services within our subscription. Remember, my friends, my name is Arturo Hamilton. I'll be your trainer during this session. So please, nothing left to say here. Sit back and enjoy our workshop. So we're going to start by talking about the usage of implementing and managing virtual networks. The fundamental part of it is the understanding, right? Well, first of all, what is a virtual network, folks? When we talk about a virtual network, we usually refer to a boundary. Think about this as a boundary limit around the region where we have the network, and that's what we get in here. It's used to have a direct communication in Azure. Okay, all the services within the network and within the resources will be capable of seeing each other, talking to each other. Something quite important, all the things that we add, all the namings, all the terminology, all the concepts are the same as we have referred to since on-prem this time. For example, if you had networks on premises that were created based on public IPs, private IP segmented, and virtual machines using the access, the same interface card concept that we know from a Hyper-V computer, from a virtual computer, from an on-prem computer applies to Azure. That's a good thing. We have a subnet, we have a segment, and everything works as expected. Now, everything that we have as dependency should be on the same region. For example, an IP has to exist on the same location. All this can be created using the Azure portal. We can use PowerShell, as we have seen. We can use CLI commands. We can use programmability or infrastructure as code, etc. So the limitations are actually the same as a physical or on-premises network with the consideration of a virtualized environment. Okay? So the first of all, it's to implement and create a virtual network. Let's go to our portal to start with the creation of a new network. If you remember, we have created some networks in the past exercises and past demonstrations. Well, we're going to go here to networks, look for the icon of networks, as you can see here, and we're going to click create. We already have a couple of networks in different type of subscriptions I can select here the subscription we have been using for these demonstrations, and you can see we have this network. I'm going to create a different network. I'm going to click on add. Let's wait for it to come out. There it is. I'm going to select in the same resource group that we're using for these specific demonstrations, and I'm going to call this VNet 02. The region will be South Central, so we can have something different. The addresses, take a look. It's giving me automatically the next available address. If you remember when we created a computer in a previous module, we were given with 10.0.0.0. The next one is 10.1. I can go here and say 10.1, 10.2, /24, for example. And I can call this a different subnet. I can use all the segments of there. I can call this subnet 02 and 10.2.0.0/24. So we have everything occupied. This is not a common practice, folks. Try to have a proper balance, okay? Try to have enough IPs and then use the subnets as division. Take a look. The first segment we have here has 65,000 addresses, and we are only using 251. So it's a best practice. Every network we create, folks, has the option of having security by default. We can enable this network to use Bastion. I'm going to show you this later today, but this is a really useful option. So I'm going to configure this right now. Okay, so we will be using that. It's going to be Bastion Workshop. We can call it like that. We're going to have here the subnet 10.0.1.0/24, and we're using, as you can see, something that is not contained on my addresses. Why is that? If you remember, on the addresses, I don't have 0.0, I have 0.1, right? So you can see it automatically detects the availability before doing something weird. So I'm gonna go and change this one, and you can see, now we're good. Now we need to add a public address because we're gonna connect to Bastion. I'll explain the usage of it. I'm configuring this because we will have an option in the future. But let's go here and add a new IP for this Bastion service. It will be an exposed IP, so we can call this Bastion-IP. And now that we have it, it's going to configure itself by default with the settings that we need in Bastion. We click OK. We can enable a DDoS protection. This is an advanced topic of security, but that's also a good approach. So I could enable this with an advanced protection of DDoS, distributed denial of service, or I can enable it later. And if I want to use a firewall, we will talk about the firewalls later on this topic, well, on this module. I'll explain why. So we're just going to create here my Bastion service. I'll explain the whole reason behind this later on the road, I promise. So we have the tags. Right now, we are not going to use tags. Remember, these are available in all my services. Let's check. We hit create. The network will be ready quite fast, but Bastion will take a while to be complete. So the whole deployment transaction will take maybe 5 to 10 minutes. The network, folks, usually is one of the fastest services to be deployed, less than 50, 60 seconds. And I'm exaggerating here. I'm overreacting on this approach. So it's just to give you some context about the times. You can see the VNet is ready. We can use the VNet now, but Bastion will be complete in a while. So we'll be back to confirm that we have Bastion ready when we need it with the virtual machine. In the meantime, folks, let's go back to our slide so we can talk about something called the peering. Imagine that you have two different networks in different regions. You can see here on the example, one in the West US and one on the East US. How will you make them talk to each other, right? Well, you can put a VPN in both, a gateway on each of them, and then use a VPN public connection using internet-facing channels to talk to each other. Option number one, a VPN, right? What if I want to use the dedicated Microsoft backbone they have for all their internal communications within data centers? Well, we have a service called the peering. I can make them talk to each other, network 1 to network 2, in my resource group and have a dedicated communication without any further issues. The only mandatory requirement, my friends, is to avoid overlapping the address spaces of the network or networks that you are planning to peer together. Let's see how we configure this. Bastion, still under deployment, as you can see. I told you it was gonna take, didn't I? Well, while we wait, we're not gonna use it right now. Let's go to our networks. We have now demo VNet and VNet 2, as you can see on my resource group. I'm going to pair them together, 122, 221, okay? So under settings, now that we have the network, I can go here and click on pairings. Under pairing, I'm going to click on add. The name will be demo to network 2. I understand the name, so let me use something a little bit more meaningful, right? Like this, to network 2. There. I'm going to allow traffic from here to that network, yes. And I'm going to allow traffic from there to this one. Am I supposed to do that? Have a two-way channel communication? Yes. I'm going to use, I don't have a gateway yet. I cannot use a VPN, so it will be completely peering. As you can see, I don't have a gateway on this one or a gateway on the other one. You can see. Okay, so I'm going to use no gateway on the setup. From there to here, what will be the name? If this is demo to net2, I'll call that net2 to demo. I know that this is the other way around. The same resource manager, I'm going to select demo vnet. You can see I have the option of not peering myself. That's because this is the network I have, right? So you have to use something different. VNet2. Traffic from here to there to here, the same, but now on the VNet 2, yes, and add. It's gonna take less than a minute, and both my networks will be now connected to each other. Using the Microsoft dedicated backbone, I can see that network, the network can see me, and we can have a full communication. Check this, peering status connected. If I go to the network 2, let's confirm, and I click on peerings, now it will take there it is, network 2 to demo, I'm reaching the demo VNet. So as you can see, the peering was created in both of my networks by executing a single sequence of steps. This is the peering, and we have now both networks available to see each other. Now, if you remember when I was creating our Bastion host, while we wait for that one to be used, I selected to have added a public IP. In Azure, folks, we have the option of creating public and private IPs. Some services will be so powerful that you can have public and private IPs on the same service. You can have two different type of exposed connections. You can use them to reach your object privately or publicly. And well, the idea is to have different type of connections and traffic management, right? Like security settings, type of maybe services, the type of protocol to be used, a lot of different scenarios. Well, private IP addressing, folks, can be used on a static or dynamic directly inside of my network. This means that I can connect privately to any of my IPs without going to the internet. I'll use my backbone. Okay, a virtual machine can connect to a private IP on a balancer, for example, or a balancer can reach a public IP of a network. The network can use that private IP, for example, for a specific addressing. Then you can have a bridge and you can make them talk to each other. In the creation of an IP, folks, is not mandatory to add an object. I think Bastion is ready. There. We'll come back later to see this Bastion working. But I can go here, say IPs. You can see here public IPs, and I have also the option of private IPs. I'm going to go for public. I'm going to click on add, just for standard purposes. You can select IPv6 or IPv4 or both. If you use IPv6, you don't have to worry because it has automatic tunneling. IPv6 over 4, Therido, etc. So it's optimized. But I can keep it up like that. If I go for standard, I can select this to be available at global access or regional access. The moment I select a standard, you can see it becomes static. So to maintain the IPs available based on a dynamic process maybe that requires the same IP always, the best practice is to keep it standard. Under basic, you can see I can change dynamic or static. Okay, so I'm gonna keep it like this. I'm gonna call this NLB IP. I'll use this on a balancer later today. I'm going to select the idle timeout. How long are we keeping the cache and refreshment process of the IP? The expose name, NLB IP. South Central US, you can see where the service will be created. I'm going to change this to East US. There we are. And put it on the same resource group that we have been using. Just like that, I have now a public IP ready to be used. There we have our IP now. So it's time to create another type of object. We have appearing our networks together and my public IP. Inside of my networks, I can start defining routings. If I create more than one network or multiple interface points, for example, an intermediate computer, I can use custom routing. So the access gets available in a public network with a public front end that then switches to a private subnetwork, then finally cached on the backend by a complete private and isolated solution. It's like jumping from to back to create like a filter of security to avoid exposing all my services out of the box into the main front end. Okay, that's the idea of using this type of routing. Again, it's optional. Not all the networks or services will use it, but if you want to have an intermediate step like an appliance computer or something, this is usually one of the best practices, the routing for the networks to jump around the different services. So now it's time to talk about the name resolution in our networks. That's our lesson number 2 of this module. What is the name resolution, folks? You might be thinking, okay, I've seen that a lot. I think I even have read something about it, but I'm not sure. What is the name resolution, folks? The name resolution, think about this as a pointer that exists for your services to have a name associated with the IP. The name resolution will be able to create that pointer, in this case a DNS service, a DNS record, that will actually let me know that Arturo's application.microsoft.com belongs to 10 point something point something point something as an IP. Both of them together to reach it out. The users can resolve this by reading out in different layers directly from the cloud or from on-prem. You can use private zones to have private IPs, as I said, on premises, maybe with a hybrid network, or you can use public zones so anyone can access via internet into a public IP. That's the objective of the name resolution DNSs. When we are configuring these custom settings, folks, we actually have scenarios to decide where do we get our zone or how it will be used to solve. Take a look on the map. This is an example of a name resolution. For example, let's imagine that you are in Australia. You want to access application.arturo.com. That's if I was the owner of my domain, right? Well, you get there. Your public zone has a public IP for that 10 point, well, 192.186 point something point something. Good. From Australia, you ping to that IP, you receive a response, and using the backbone of Microsoft, you start jumping around until you get to the host where the application was created. In this case, we might be talking about South Central US. We have the data center in Texas. We're connected there, and the DNS help us to get the resolution path and point in the map where we are supposed to land. There is no infrastructure needed for this, folks. It's all about resolution names on a public protocol of DNS zones. That's how this works. That's the DNS usage of Azure and the custom settings. So when we have these DNS zones, we have to understand that the pointer that we were referring to will be defined by a record. There are different records we can create, folks. A host name, for example, for a domain. We can create a mail exchanger. If we want to hybridize Exchange on-prem with Exchange in cloud, well, we can use this type of record to point out where the mail is supposed to land at the end of the delivery process. We can go and state a source of authority, a SOA, that will be used to point out where are we inheriting the attributes of the pointers. For example, take a look on the diagram. We can add canonical names. What is a canonical name? You expose something for your users, for your customers. You go and say application.com. But guess what? That application.com uses the CNAME to actually have the meaning on the back. So application.com is the address the user or the customer will capture and type on the browser. You know that application.com will point to application.arturosapplication.com, but you don't expose that internal rule, right? You actually keep it secret by using the canonical name and the full qualified domain name. This is the approach of the DNS zones, my friends. Okay? One of the features, one of the characteristics that we can use to actually drive the way we solve our names. All these zones can be used also as a security protocol or as a security layer, if you will. There is an option, for example, before I get into the next lesson that we have here on screen, that is called the split ring, where we can expose something that will point to a complete different something, for example, the canonical name, and that way we will avoid showing or actually letting the external users know what the hostname resolution is. But enough about the pointers, folks. We have now the security topic. Let's take a look. When we talk about security, there are a lot of different things. There are services, there are features, and there are settings that we can use for security. Let's take a look in here. When we talk about securing the access, one of the first things that we might want to consider are the principles of defense in depth. Okay? In order to have the best security approach possible, the best practice is to have multiple layers. For example, on the exposed front end, you may have the Bastion for the computer. You may have an actual firewall, or you may have a routing solution. Then in the middle, you may have a balancer. You may have an application gateway. You may have, I don't know, a port forwarding security group, a rule internally that switches. And then on the private part, another security group, another security layer. The idea, folks, is always to have multiple front ends that we can use. You can see here we have a few services that we can list. Let's take a look on each of them so we understand how they work and the options of security that we have. The first thing that we have on the front, it's the Bastion. Okay, we have the option of adding the Bastion, for example, for the whole protection of security on the front. The Bastion, folks, it's going to work as an intermediate layer of communication. Instead of connecting to the virtual machine via remote desktop sessions or direct connectivity, you connect to Bastion, and Bastion on the back connects to the service. The service being a virtual machine. We connect via this interface and we're good to use the services as a remote desktop session. I'll show you this one in a second. We can also add a firewall on the front end, a firewall to have a static IP that will always receive the traffic as a funnel and send it to the back after filtering specific rules. For example, filtering the port, the protocol, the type of service, the IPs of the incoming request or the destination request, etc. We can protect against distributed denial of service by mitigating the actual overflow of resources on a service by dropping connections whenever they seem to be uh, anomalous traffic. Okay, that's another option. We can use security groups, application and security groups for networks. That's like putting a list of semi-firewall rules over a network interface card or over a virtual subnet. And then filtering. For example, the firewall may be open for a specific type of traffic that will then be blocked on one of the computers behind all the others. Check this diagram. If we have the virtual machine 1 in a different network than the virtual machine 2, the firewall can receive them, use a routing table, send the traffic, and then VNet 1 will block the traffic while VNet 2 will allow the traffic. That can be achieved by combining a firewall with a network security group. Okay? But now that we're talking about this network security group, let's take a look. So that security group, folks, will be a list of network security rules, as you can see here, that we can use to have that granulation. You will configure a priority being 100 the top and 65,000 the bottom. The smaller the number, the higher the priority. You will configure the name, the port that it's been the target, the protocol or protocols, and the source. The destination port, and you'll decide if it's allowed or denied. Okay? Default rules are created here when the moment we deploy a computer in a network. 65,000, 65,001, and 65,500 are allow all the traffic, allow the balancers, and deny all the traffic being the last. The idea is that we can use these to prioritize in case of an emergency, kick them up, reducing the number, and filtering everything that we have. These are options that we also have to filter our security. Okay, let's take a look in here. If we go here to our portal and we open the virtual machines, you might remember we created one when we were working on our module number 3 about computers. Well, in here, folks, if we go to networking, you can see we have the remote desktop session and the HTTPS that I configured when creating. These were created according to my settings. If I try to connect right now, I can go here, start my computer, and once running, I can click on connect, get the RDP, the session, and use it. Okay, I can go here. You can see the port is the same port. Let me download this, but it's the same port that I have here as allowed. As you can see, if we scroll to the right, you can see it's allowed, and we're good to use this. Okay, what if I want to block, for example, the traffic to a SQL service? We know 1433 is the default one, right? So I can go here, say any source from any port that tries to target my computer. I can add this IP address or any object with, you can go here and say SQL, for example. You can see 1433 is blocked. If you don't know the port, you can select something custom and leave it like this. Any type of protocol will be blocked. I'm going to put this almost to the top. Try to leave 10 spaces between the priorities so you can have enough management in case of an issue. I can call this SQL blocked. You can see here deny and add it. I'll have a complete new security port rule to block SQL from being used. You can see there, it's all the way to the top. So how do we test that the computer is working? We can go here. As soon as it's running now, you can see it's running. I can now use my connection. I can go here, say connect. I can try to use a local account. We have, this is admin. and I can add a password. Remember that we configured this when we were working with the computer, and my attempt will be mapped with this. This is an option that we have by using remote desktop sessions. For example, if I don't want that to work, I can go here and say, block this port. Your RDP session will be denied. There it is. I can call this, for example, R priority 300. I can change this. If I change the service to any under custom, let me grab here our custom one. I think the custom, yes, here it is. I can go and call. If I change the name, it's already created, but I will be able to say RDP deny now. I can click on save, and you can see now, just like that, RDP is now denied. As a best practice, folks, our computers should be blocked from public traffic, from public access via RDP. That's usually one of the first ways of attack. How do we filter that? Well, I can go here and change it now to use my Bastion that we were talking about. Let's see that. Remember, there are some considerations that we need to know and understand about the security groups. For example, as we said, these are a group or a combination of security rules, right? Well, there is something important. We might want to have the creation directly done via decisions. Like if a new port it's requested, well, how do we trigger a new creation, right? Well, we can use PowerShell and some runbooks to do that. Once created, as you were saying, well, this new specific security group can be added and associated or created directly from my computer as I did. I can go to the portal, say here security group. You can see here, add the security groups and try to add it. I can click here add, and it will do something similar to what I was doing. I can go and say create it here, give me a network security group -2, create this on the East US, tags, and create it. This has no rules. What's the difference? The one I created on my computer was given over my network and over my virtual machine the moment I deploy the virtual machine. This is independent. Once created, once I have it, I can associate this. There are different types of association. For example, I can associate to a softnet or I can associate to a network interface card. My virtual machine has both a network and a network interface card, right? So I can add multiple security groups for each of the channels. The idea of a security group, folks, remember, is that you can granulate the traffic. If my network has one security group, let's say we are blocking UDP traffic, and I add a second interface card to my computer and I block TCP traffic, but I allow UDP, well, we will have an egg teaming approach. My computer can handle both, one of them protected by security group A and the other one protected by security group B. So as you can see, this specific approach is quite common when we want to have advanced management or complex management of traffic for one or few resources behind my network. That's the whole objective of associating. Now, after we associate, we have the chance of evaluating the results. We can see, based on all the rules that we have, which one will take priority over the others. Okay, remember, the smaller the number, the higher the priority. So if we have something on 100, nothing will be beyond that. As I said, try to avoid using the top 100. Try to use 110, 120, something like that. But if we go back to our security group, the one we were creating independently, you can see I have my rules in here. I can go to inbound security rules, and you can see I have the default. I can add some new rules. I can add some other rules. I can associate this to one of the services. I can click associate, and if this one was empty, I will be able to use it. Okay, that will be an option that I had. Once I have a security group associated, let's check the one on my virtual machine. Let's open this one and go to network. You can see here I have the option of effective security rules. I can click in here and you can see all the rules that I have and how are they being granulated according to the priority. You can see which one is on the top and which one on the bottom, well, as soon as they pop up, right? And you can see here, any type of IP used from any port that tries to target any type of IP will always be blocked. I know this was my intention. This is my design. Okay? So this is one of the options that we have. We can validate and modify the rules at any moment as long as we are the admins of the security group or the network. And this will give me control over the dynamic filtering that might have to be executed or that might have to take place in order to complete a business scenario. These folks are our security groups. Another security service that we have is the firewall. The Azure Firewall, folks, is capable of creating a complete intermediate protection between the incoming and outgoing traffic and the actual target services. This is a service that we can create on demand. We don't need an operating system, we don't need a server, we don't need infrastructure. The firewall is created as a service over the network that we will use to consume. We can have one rule, we can have multiple rules, we can have dynamic rules. The idea of a firewall is to be stateful. This means that based on the combination of variables of my traffic, I'll be capable of receiving, registering, or canceling. You can have network rules, you can have full qualified domain names, you can filter, etc. Important. If you have redundancy or high availability requirements, more than one firewall will be recommended to avoid the traffic from skipping or working around our firewall security policy. The firewall, folks, can work as a central controller, as you can see on the diagram. The traffic might be received in the firewall and sent via firewall to different networks, to different regions, even to an on-prem location if needed. The firewall, folks, can block all the traffic whenever it comes or whenever it goes based on the decision of my filter rules. That's the idea of a firewall, folks, to have this type of dynamic allocation. Okay, the firewall, important, requires a dedicated service to work. This service is a virtual subnet only for it. This is because the firewall is going to use the available IPs that you assign on that subnet to allocate the traffic to the backend whenever it's required. Okay, so just as a tip, folks, be careful with the firewall because you may have some list of prerequisites to meet before you deploy. Once ready, you can apply rules the same as the security group, but at the global front-end level of the firewall layer to block and protect all the traffic of a full network. The next service that we have, and now it's finally time to talk about it, it's the Bastion. The Bastion, as I was mentioning, folks, is going to work as an intermediate layer to connect. Using a browser, using Edge, using Explorer, you can connect to Bastion as long as you have the user and the password, and you'll be able to reach the computers on the back. Bastion will always have available IPs. If you remember, we created also a dedicated subnet in order to have something to allocate the front-end request to the private IP assigned to my network. This is the principle of Bastion. Bastion can be used publicly on any endpoint location without sacrificing or without compromising my solutions. Let me show you here. Let me show you how Bastion works. So now we go to the portal. We click the virtual machine that we want to connect via Bastion. And here we click connect. I type Bastion and I click on use Bastion. I'm going to use that intermediate layer that we have been mentioning. All this is browser. I'm going to go here and use, remember the local admin we added to the computer when we created this. Password. We click connect. It's opening a new browser page, you can see. And Bastion is now giving me the access just for you to see. Take a look. It's an actual browser. That's how Bastion works, folks. You can see the connection is done directly over the service, and we get using the browser to the virtual machine like if it was a remote desktop session. The next thing that we can configure, folks, and it's our next lesson, is the actual balancing process for incoming and outgoing traffic. we have the chance of using Microsoft services as balancers to create this experience of dynamic allocation of traffic based on how we define our cluster of computers to use it. Okay, we're going to create a balancer on this lesson, and you will see how this is useful on a front end because you can receive a single request and always select the best solution possible based on the computers on the back with a round robin, or you can use advanced balancing options with some other scenarios. The idea of load balancing is to distribute the traffic according to my workload needs. So let's take a look in here, my friends. The first thing that we have, it's the configuration. So as we were saying, we have different options to actually balance our solutions. A load balancer in Azure, folks, will be based on infrastructure as a service. The resource will be created, physically speaking, in the region that we select. The important part of this, my friends, is that the load balancer can work on the layer 4 internally or on the layer 7 for public traffic that is coming to my solution. A simple definition. In Azure, folks, we have the chance of using this type of balancer to catch and get our service working. We can avoid single point of failures by adding multiple types of balancers to the same solution. If one of these instances that we put under the balancer as part of the pool fails, the balancing will keep monitoring the others to always redirect to the best solution possible on the instances. It's important that we remember that a balancer can have one computer or 1,000 computers on the back. There is no limit on the number of computers we can have, at least on a standard approach. When I say 1,000, that's our limit. But with 4 computers, we have redundancy of granulating up to 25% of workload per computer, right? So that might be enough. This is one of the options that we have. But let's take a look on the portal on how to create a balancer. Let's take a look here in our portal. So we're going to go here and say load balancer. We select the option. We're going to add in here a new balancer. Let's create here on the resource group NLV demo. We will put this on the East US coast. We're going to have public and basic. The difference between a basic and standard is that basic has free balancing options but is limited to 300 computers, and also it has no mandatory usage of the security groups that we explained before. So, well, if you have an advanced security approach, you might want to use something different. So I'm going to go here. Remember we had an IP? You can see the one we created before on the module. It's now available. I can add an IPv6 if I want, or keep it simple. I'm going to keep it up like this. If I go standard, you can see here, the IP can also be used, and now the balancer can be reached globally or based on a region. Think about a geopolitical division like a country. Okay, so that's just to show you some of the options that we have. No tags, create. We just validate the content that we have, and we hit create. The balancer will be set up and will be good to go and configured. So we'll wait here a couple of minutes. Actually, you can see it was faster than a couple of minutes. That's good, right? Let's go to the resource, and we have our balancer. In order to make it work, we're going to have to follow multiple steps in a sequence. The first thing is the IP. We already have that. If you remember, on the front-end IP, we already got it. I can add another IP if I want to use a different type of incoming traffic or something. Okay, that's also an option. But this is already checked. The next step is the backend pool. These will be the computers or services that we're going to have on the back of the balancer to select from when we receive a request or a petition. So I'm going to go here and add. Let's call this back and pool demo. We're going to put this on our virtual network, virtual machine. You can see there is no virtual machine yet, so I need to add a virtual machine. Okay, my computer, it's in a different region. That's the reason why I cannot select it. Remember what we said when we talk about the network and the limitations of the boundaries, right? Well, as long as the service as a dependency exists on the same region, we will be able to use it. So since my computer is on a different region, we cannot select it in here. So be careful with that. I'm going to click add. and it's going to add a backend pool without a computer. This is useful. This is a useful demonstration because, as you can see, it's not mandatory to have an actual virtual machine to create the first instance of my balancer. So there goes. We'll have the backend pool ready, and we have the first two options. The next thing that we have is the health proof. This is to communicate the frontend IP to the backend pool. So the health proof, it's our next object. Let's click add. Let's call this health proof demo. You can select a different protocol with different ports and paths. I'm going to use TCP. The minimum, it's 5 seconds in 2 tries. You knock once, 1, 2, 3, 4, 5. If the second one fails, you automatically jump to the next computer. Check this. If I go 4, it says the minimum is 5 seconds. If I go here to 1, to 1, the minimum, it's actually 2 attempts. Okay, so I have these two. I'm going to click OK. And we will have now the frontend IP, the backend pool, and a proof to connect them together. We'll wait here a couple of seconds and we'll have the health proof ready to configure the final options. There it is. We have a proof now. Let's go now to the next step, that is the load balancing rules. This is to create the actual sequence of communication between the frontend IP, the backend pool via the health proof with a list of setup rules. That's the whole scope of this. Let's click on that. And here, I'm going to start by adding a name. This will be, let's call this rules. Since we have a public IPv4 and we have a private IPv4 in our subnet, in our network too, we're going to select that one, the frontend IP that we created with TCP. The ports that we're going to use, we can change the port as a best practice, for example, just to secure the traffic, okay, to avoid the usage of a public global port that was it might be usually first attempt of guessing. We can add stickiness. Well, let's use a correct name, session persistence. I like to say stickiness, as you can see. And from there, we can select if a client IP on the client IP and the protocol will actually drive the connection. Everything is good. We click OK. And as easy as that, my friends, our balancer is ready to be used. If I add a computer now on the East Coast, I can go to the backend pool, modify the pool that we already created, and add a computer. It's already created, yes, but if I go here, select a different one, and select my computer, I'll be able to add it now, even though it's created. So as a recommendation, set it up first and then go for the advanced management or the ongoing approach that you might want to take. So this is our balancer. We have another solution that we can use to balance instead of using just the balancer. This solution, folks, is the application gateway. Imagine the application gateway as a balancer on steroids. You have an option to pre-execute before the balancing Windows application firewall rules, filter and confirm the application behavior, the transaction behavior, before letting the balancer go through and actually select the object on the back. The application firewall, folks, that we have can be configured for in and out. The application gateway can receive traffic from layer 7 and layer 4. The trick in here is that we have them both together. The balancer can only be used in one or the other. On the layer 4 or the layer 7, we can have public or private. We will discuss this on the next one. While the gateway has the chance of consuming traffic from both. So imagine this. You have a petition. The petition gets stopped because of the protocol. The protocol authorizes the petition and then you go to the gateway. The gateway selects the objects on the back, redirects the traffic, balance based on the best practice, and releases the transaction to the destination selected on it. The application gateway, folks, it's one of the best options when we have simultaneous traffic requests or something that might be a little bit beyond our requirements, okay? The standard balancing might not be enough. And that brings me to what I was mentioning, an internal balancer. An internal balancer, folks, will always have an approach, will always have the requirement of running with a private IP, while the public one that we saw, it's on the layer 7 and uses a public IP, right? Check this. If we go back to the balancer here and we open the balancers again, I can click on new, and instead of creating a public one with a public IP, the only thing I need to do here is to create this. There it is. Let me go here to the demo. Internal load balancer. I can select here internal, select a network, and then just add a static IP. I mean, this is a best practice, but you can also use dynamic IP if needed. We can create it like that. You can see it's a static on the private subnet that I selected. I go next and click create. I have a functional balancer now for internal traffic control. All the things we saw on the previous balancing option where we have to configure different type of attributes also apply in here. Backend pool, health proof, balancing rules. Remember, the balancing is one or the other. While if we actually use an application gateway, we have the chance of executing this on the two layers at the same time. This is good. We're good. We have a balancer. And as you can see, we have now the same settings and attributes that we discussed before. You can see here now for the internal balancer, front-end IP, backend pool, etc. These, folks, are the options to balance in our networks and fully ready to be operational as expected. Our next topic, folks, the one that we have now ahead of us to continue with the network scenarios, it's the usage of monitoring solutions. You might be thinking, okay, we have talked about a lot of different options. We have talked about a lot of different solutions for networks, but how do I keep an eye on them? How do I actually monitor this option? If, well, being honest, we haven't done that in the past. Let's see. When we talk about monitoring, folks, we have different services we can use for this purpose. So what we're going to use now, it's one of these services to start with. This service is the monitoring of virtual networking by using the monitor services of Azure, a service that is included in every single solution and subscription that we select to use in Microsoft Azure. This monitoring service, folks, exists by default in every single object that we access. Let me show you here. I go here, scroll down and look for the blue speedometer. Here it is. We click on it, and you will see that we have actual monitoring service. In here, we have multiple types of monitors, multiple type attributes, and if we scroll under the insights, you'll see you have the networks. Let's open the networks. Under the networks, folks, we have optimized attributes to monitor my subscription, specifically talking about the virtual network options. Under this monitoring, folks, as you can see, we can find a lot of different options, like the balancers we created, the network interface cards that we have used, the security groups that we have, the public IPs, and click on each of them to see the actual service and the objects that we have inside of it. You can see here the balancer and the two balancers we created earlier today in the previous lesson. I can go here and check connectivity, and you can see here my virtual machines, if they are actually running as expected with my services, with my network, right? I can go back, check my virtual networks. Here, for example, the network security groups. And you'll be able to see here the security groups we created earlier today for the interface cards and the subnets. So all the things we have by default will be shown in here. Now, there are different categories we can also include if needed. So from here, we also have to decide if monitoring is what we need, because we can also monitor on-prem solutions, on-premises networks. For example, if we have a VPN, something we will see on the final module of the topics we have, you'll see that when you have a VPN, you can connect and read from an on-premises location. You can see here on the screenshot, take a look. I have the VPN, I have two VPN gateways running at the same time, and I can see if it's started, if it's actually running, the network that is hosting it, and I can even troubleshoot from here if needed. There will be scenarios where this specific option of monitoring will always give me the chance of having even a pre-result of the possible issue that I might be facing. So I can have an idea of the actual issue by reading from here. So as you can see, this is one of the options that we have to monitor the on-premises too. Remember, we're going to talk about that in a second, okay? What else do we have? We also have the chance of checking the performance of my network. And now that we're talking about on-premises monitoring, remember that we also have the chance of using the Network Performance Monitor. This option will let us monitor cloud technologies and also, if possible, and if needed, on-premises technologies that might be synchronized or hybridized with our network solution. It requires the usage of something called the Log Analytics Workspace. That is an option with a different type of subscription where we can centralize our logs. Okay, that's one thing that we have to remember. The performance monitor, folks, will help you to actually check the connectivity between on-prem and online, will help you to have all the services to see if they are running up and available. And if we have a direct circuit for express routing, that will also be included on the monitor, showing in real time, whenever it's needed, all the services that might be consuming that dedicated circuit. Okay? These are scenarios that we will be facing when we have the performance monitor in mind. And finally, remember that we also have on the advanced insights the option of using something called the Network Watch. The Network Watcher, folks, is one of those services that we can use to monitor advanced scenarios and to keep an eye on every piece of hardware and every piece of information that goes through my virtual network. In here we have a visual support with different type of technologies to execute traces, to execute pings, to go and modify all the rules to check the validity of them with effective security rules, like we did with the network security group. We have a connection monitor and the connection performance that we were mentioning before. We can create a topology map, a complete visual topology map of my network without impacting or without using an extra subscription. We can troubleshoot the VPN as we mentioned before. We can capture the packets of an actual communication to have a real-time uh, snapshot, if you will, on how my network is behaving. We have a real-time connection troubleshooting tool that will analyze the network on premises, in cloud, third-party clouds, etc., to say this is the error. This specific option is free, folks. The Network Watcher comes with every subscription. We can use it from the insights of the monitoring services of Azure. Something important, the Network Watcher, folks, it's always going to be there, but keep in mind that there might be some issues detected on the connectivity that we might address directly fixing the services instead of following sometimes the recommendations of the Watcher. To keep it simple, the idea is to use this as a supporting tool for the optimal functionalities of my traffic. And finally, folks, for the last lesson of this network module, we will talk about the integration hybrid between cloud and on-premises networks, the hybrid network technologies, folks. This hybrid network technology, it's based on the communications between an external endpoint to Azure and the Azure network subscription. This can be a third-party network provider, for example, something in Google, something in Amazon, something in a third-party private cloud, or the on-prem integration with my head office, with my branch office, with my headquarters. To achieve this type of connection, folks, we're going to use a gateway. The gateway can be used for express routes or can be used for a VPN standard. The idea of this gateway, folks, is to create a full interactive connection between my cloud technologies and my on-premises technologies. The service we will use to achieve this, it's called the VPN Gateway in cloud and the local network gateway on-prem. The VPN Gateway in cloud will be existing in one of my networks to receive the traffic that comes from the local network gateway. The local network gateway, folks, will have to be mapped to a public IP that we have exposed physically on our location where we want to hybridize. My on-prem network, my third-party cloud network, my private cloud network. That IP will be related to my front end, to my service that I have in Azure, and both of them will talk to each other using a direct communication channel that is called the connection. The Azure VPN Gateway is required, and the local network gateway is required on-prem. Now, something important, if you remember the peering that we mentioned at the beginning of this module, we also have the chance of putting a VPN gateway in both networks, network 1 and network 2. Both of them will be able to talk to each other, and we can use the VPN traffic to make them see and work together. So the idea of integrating network to network, it's not only exclusive for hybrid scenarios, folks. We can go to VPN in cloud, S2S, or we can go VPN to on-prem and use, for example, an IPv2 IPsec connection with encrypted connectivity, but always over an internet traffic approach. At the end of the day, having this type of approach will reduce the dependencies we might have for other type of connections or services, right? We can use an internet channel. I can connect, for example, via remote connectivity desktop from a traveling place to my head office, and then from there use the VPN or the direct circuit to jump into Azure and process anything that we might have the need of processing within that context. This is one of the options that we have. Now, this is how it looks. When we put them together, you can see here, I can have on-prem VPN gateway to a gateway subnet in cloud, as I was mentioning, or I can have VNet 1 to VNet 2. The difference, folks, and remember this is pretty important, is that if I put VNet 1 to VNet 2, I'm using a public traffic connectivity, while the peering that we covered at the beginning of the day, it will be using the actual backbone of network that Microsoft uses for the communication between data centers and their regions. So that one being the fastest and most secure approach, but keep in mind something. You might need to prove to have the hard evidence of your traffic being secure, encrypted, and protected on a VPN connection. In that scenario, well, as I was saying, the part one of this diagram, the top one with network to network in Azure, will use my gateway. What happens if I have a heavy throughput demand? What happens if the VPN seems to be short, seems to be running out of capacity, and it's compromising the user experience? Well, we have another service, and this is the final thing we have, that we can use to achieve that goal. This service, folks, is called Azure ExpressRoute. This is a specialized type of connection, my friends, that you can use to reach the Microsoft network via the available partnerships that will work on your area. The objective is that you have optimized connection with a direct private link from your internet service provider or the actual circuit provider directly to Microsoft. You don't use an internet connection. You don't use a public connection. No, this is done directly over a dedicated channel. You can have up to 10 gigabits per second. It's useful for migrations, for data loads. It's useful, for example, if you have multiple services, Microsoft 365, Azure, Microsoft Intune, Dynamics, all of them running on hybrid scopes with SharePoint, Exchange, Teams, Skype. Well, ExpressRoute might be the best practice because you'll have all the Microsoft services running on this specific highway. So ExpressRoute, folks, will use the same, a gateway, but a dedicated circuit by the internet provider along with Microsoft will offer the solution that we're talking about. So it's not optimized for slow processes, or it's not optimized for a non-critical demand service, but it's actually a nice practice, as I said, for the examples of heavy throughput and heavy bandwidth usage demand. It looks like this. When we set it up, you can see we have the on-premises network, we have the virtual network in cloud, we have a virtual gateway, the subnet gateway. Instead of configuring the gateway for VPNs, we're going to configure the gateway for ExpressRoute. We will connect them together, we will make them talk to each other, and the circuit will be dedicated in here. So my traffic will use this new gateway we have created, and will be good to go for a heavy demand traffic whenever we need it. With all these principles in mind, folks, we can actually create an Azure Virtual wide area network. We can put gateways, we can connect peering services in cloud, we can connect them all together into Azure to create a dynamic multi-channel connectivity within my services. We can extend beyond Azure. We can use the services we discussed today, the peering, the network gateways, the VPN or the ExpressRoute gateways, create the central hub to have transitivity between the services so you can jump from point A to B to C back to A without actually having to create direct connectivity endpoints between each of the involved objects. The central hub of the diagram is the one that will catch all these type of variables, will expose it, and will be good to go. And this, my friends, it's the final topic of this module. We have talked about a lot of network features. To wrap it up, folks, I would like you to remember that the network is one of the most complex approaches of management in Azure because of so many services and characteristics we can use. At the end of the day, what we saw today, or what we saw in this module of the workshop, it's a summary of the different approaches. My recommendation, folks, is play with the services, check the official content of the training paths of Microsoft, check the official documentation on the white papers on Microsoft Docs, and you'll have a better understanding at deep level of the technical functionalities of this. Again, thank you very much. My name is Arturo Hamilton. I really love these type of sessions with you. I hope that you enjoy the session we are wrapping up, and I hope to see you the next time for the next module of this Azure Management Workshop. Thank you again, and until the next session.